Good evening. Yes. Okay. So in the last class, we have discussed about continuity. Okay, not limit and continuity. Continuity is discussed in, but not in the full form. Okay, I have just explained one example and one continuity example, which is a mod x or mod of x minus a, the function like that. Okay, and I have also explained the mod function, that is either mod x or mod of x minus a with a software. It is how the function actually, the formation of the function. And so now today we will start with the continuity, the exact definition of continuity. Though this example, one example has already been done, and you all know that the limit x tends to a plus, that is, this is the right hand limit. The right hand limit is equal to the left hand limit and is equal to the functional value at that point a. If these three values are equal, then we can say that yes, the function is continuous at the point a. Okay, and we have already discussed about the continuity of mod of x function. So a function is continuous if the left hand and right hand limits are equal, and which is equal to the functional value at that point. Remember that continuity is defined on a single point. Okay, so a function is continuous. Suppose a function fx, suppose this is a fx function. This function is continuous. Okay, continuous means it is, if I say this function is continuous for all x, this is the symbol of for all. It means if I extend this into the plus infinity, and if I extend this region into the minus infinity, okay, that is the total interval is minus infinity, comma infinity plus infinity interval, then the entire function is continuous at each and every point in this interval. Then this function is called continuous function. Okay, so continuous function throughout the range of x, that is through minus infinity to plus infinity, throughout this range this function is continuous. And if I define the continuity in a single point a, then we have to specify a single point a at which the function is continuous, that is this property holds at this point. And if I say the function is continuous throughout the range of a, that is up to minus infinity and plus infinity, then it means that this function at each and every point within this interval, this property holds, that is the function is continuous within this range. Okay, next, what we have left in the last day is differentiability. This is the definition of differentiability, that is limit h tends to 0 minus. 0 minus means this is the minus, means this is left hand limit, okay, and this is h tends to 0 plus right hand limit. Okay, so at x equal to a, if this property holds, that is the left hand limit of this one and right hand limit of this one is equal at x equal to a, then we say the function is differentiable at limit h tends to 0, that is this function is differentiable at this point a, x is equals to a. Now I will explain today the differentiability of the mod function. Suppose fx equal to mod x. Okay, fx is equals to mod x. And this function, you know that the definition of mod function I already discussed in the last day is minus x if x is less than 0, is equal to plus x if x is greater than 0 and is equal to 0 if x is equal to 0. So this is the definition of mod x. Minus x if less than 0, plus x is if greater than 0 and equal to 0 if x equal to 0. Okay, and you know that the continuity of fx function, if mod x function is continuous, as I already discussed in the last day, that is according to the definition of continuity, that is this definition of continuity. Okay, you yourself has already solved this problem. It is how this function is continuous. But I just told that this function mod x function is differentiable, but sorry, not differentiable. But why this function is not differentiable, I didn't disclose it. So today I will check the differentiability of this mod x function. Okay, so let's find it out. What is the definition of differentiability? This is the definition. Limit h tends to 0 plus fx plus h minus fx by h. Okay, first let me 0 minus left hand limit f of x plus h minus f of x divided by h. So I will first find this limit. Okay, so let us find this limit at which point, suppose I am differentiability at x is equal to 0. I am finding at x equal to 0 point the function is differentiable or not. Okay, so that is why I am putting the value at x is equal to 0 here, because I am finding the differentiability at x equal to 0. So limit h tends to 0 minus f of 0 plus h minus f of 0 divided by h. Okay, so this equal to limit h tends to 0 minus f of h minus f of 0 divided by h. So now look at this. Already I explained fx function. Okay, fx is equals to mod x. Now fh, what is the value of fh? Obviously it is mod of h. Just I am replacing this value x as a with h. Okay, so x is replaced with h, so it is mod x. So I am just writing here mod h. And according to this definition h, so everything it is changes. So that is, this is equal to minus h if h is less than 0. This is equal to h if h is greater than 0, and this is equal to 0 if h is equal to 0. So the definition will be same. So f of h, if I consider h tends to 0 minus, that is I am approaching from the left side. If I am approaching towards the left side to 0, then obviously it becomes h less than 0 portion. So the value is minus h. So limit h tends to 0 minus, it is minus h. Okay, f of 0, that is f of 0 we already know, when h is equal to 0, the functional value is 0. That is x equal to 0, the functional value is 0. So at 0 point the function is 0. So that is why f0 equal to obviously 0 divided by minus h. So what is the limiting value? Limiting value is minus 1. Okay, now let us find limit h tends to 0 plus. So this is equal to limit h tends to 0 plus f of x plus h. So I am putting again x is equal to 0. So it becomes fh minus f of 0 divided by h. And this is equal to, look at this. Now it is h tends to 0 plus. 0 plus means I am approaching towards the right hand side, and right hand side means it is plus h. Look at the definition of this one. If h is equals to mod h if minus h if is less than 0, is equal to plus h if h is greater than 0. Greater than 0 means I am approaching towards 0. Obviously fh equal to plus h in this case. limit h tends to 0 plus h minus f0 is obviously 0 divided by h, and h will be nullified and it becomes 1. So now look at this, the right hand limit is 1, the left hand limit is minus 1. So right hand limit h tends to 0 minus is not equal to the left hand limit. So that's why this function, mod function, is not differentiable at x equal to 0 point. Okay, anybody has any kind of doubt? Any clarification?
No, sir.
Okay. Then now the question, how the questions will be there in the in GATE exam. The questions in general, instead of a single point, that is suppose a function. Now I will already I have discussed about the trick, how to find out the differentiability of mod at some point. So again I am discussing about this trick. If some function is given to you, suppose mod function f of x is equal to mod x. Okay, and you know that if f(x) equal to mod x, it can be written as mod x minus 0, or you can also write mod of x plus 0. That is 0 is plus or minus, it doesn't matter. Okay, so fx is equal to either x mod x, it means this function fx function is not differentiable in 0 point or at 0 point. At 0 point. Instead of mod x, if suppose the function fx is given as x minus 10. Okay, tell me at which point the function is not differentiable. I'm giving you 4 options. Option A 0, minus 10, 10, all differentiable.
At 10, sir.
At 10.
Sir,
Okay,
at
please
10.
write down in the chat box. Everybody write down in the chat box. If the function is given as fx is equal to mod of x minus 10, then at which point the function is not differentiable? Okay, so everybody is saying that it is 10 point. Yes, it is 10 point because it is x minus 10. Okay, so x minus 10 means at 10 the function is not differentiable. Now sometimes instead of a point, some interval is given to you. That is fx function x minus, is it differentiable in the interval 0 comma 10, closed interval 0 comma 10? Is it differentiable? Instead of a point, now suppose an interval is given to you 0 comma 10. Now you are saying that is fx is equal to mod of x minus 10. Is it differentiable in 0 comma 10 interval? Look at this interval is a closed interval. So closed interval means both 0 point and 10 point are included in this interval. Okay, that is 0 and 10 everything is included. I am talking about this interval. So remember that if these kinds of questions occurs, then first of all you need to find out at which point the function is not differentiable. You know that at x is equals to 10 this is not differentiable, and you need to check that whether this point included in this interval or not. If this point is included in this interval, then you can say yes, it is not differentiable, otherwise it is differentiable. Okay, that is, if this range 0 10 is replaced with 0 5, then obviously this function is differentiable in between this range 0 5, because 0 5 is here, and this function mod of x minus 10 is not differentiable at this point. But if the interval is 0 5 interval, obviously this function is differentiable function. Okay, so to make you confuse, some cases in GATE exam, these kinds of tricks may be applied. That is, an interval is given and you were asked that whether the function is differentiable within this interval or not. Maybe it is differentiable, it may not be differentiable. Okay, it depends on the points at which the function is not differentiable. So whether the point lies in the interval or not. Okay, similarly, is it differentiable in is this function mod of x plus 10 is differentiable in minus 100? Just say yes or no. Okay, some student says no. First of all, we need to check that whether this function is differentiable at the point, which point the function is not differentiable. Okay, so tell me at which point the function is not differentiable. This function is given as mod of x plus 100. So at which point? Yes, minus 100 point, exactly. So if it is minus sign, then the point is positive. But if it is plus sign, then the point will be negative. So x is equal to minus 100, at which the function becomes not differentiable. Now we have to check that this minus 100 point is differentiable, is included in this interval or not. We can see that minus 100 point is included in this interval, because this is closed interval minus 100 comma 100. Since it is a closed interval, then we can say yes, this minus 100 point is included. So if minus 100 point is included in this interval, then this function is not differentiable. Okay, sorry, yes, not differentiable. But if I write like this or this, this is called open interval and this is half open, half closed. In this case, both the cases, you see that minus 100 point is excluded of this interval. So we can say that yes, this function is differentiable in open interval minus 100, but not in the closed interval minus 100. So these are the tricks which may be applied in the GATE questions. Okay. So any problem, any doubt?
Excuse me, sir.
Yes.
So actually, I was late to join the class today, sir.
Okay.
From this problem, I got to know that if suppose the value is becoming zero, after substituting the point, it is not differentiable. Is that the
Zero.
definition?
No, 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 not zero. Uh, Forget about the definition. Any differentiable function, that is if any mod function, in general in gate examination this kind of function is given to you. If some polynomial function or trigonometric function is given to you, simply you can apply the differential rules. Okay, that is the differential of sine x is cos x, or differential of x square equal to 2 into x, like this. Simply apply the differential. Don't have to apply the definition. Okay, but in this kind of cases where mod of x, which the function which is not differentiable. Okay, so if mod function is given to you, then suppose x minus 10, this function is given, mod of x minus 10, then this function is not differentiable at x is equals to 10. Okay, similarly x plus 10, mod of x plus 10, this function is not differentiable at x is equals to minus 10. So if the in between this symbol is a plus symbol, then this function is not differentiable at x equal to minus 10. And if the this symbol there is in between this symbol is minus, then we can say this is equal to 10. At x equal to 10, the function is not differentiable. Okay, now in some cases an interval is given to you. Suppose that interval is 0 comma 10 interval. Okay, this function x is x minus 10, mod of x minus 10, is this function differentiable in between this interval 0 comma 10 or not? First of all, you need to check that at which point the function is not differentiable. So which point? 10 point, x is equals to plus 10. So you have to check that the 10 point plus 10 point is included in this interval or not. If it is included, then the function is not differentiable within this interval. But if the suppose 0 comma 5, this interval is given to you, and you are told that mod of x minus 10, is it differentiable within this interval 0 comma 5? Yes, obviously it is differentiable, because mod of x minus 10 function is not differentiable at x equal to 10, and 10 point is not included in this 0 5 interval at all. So you need to check that whether the differentiable not differentiable point is included in this interval or excluded in this interval. If it is included, only then the function is not differentiable. If it is included, then it is excluded, then it is obviously differentiable function at this interval. Okay, got my point?
Yes, sir. For mod function, I understood, sir. For any example of a trigonometric function, sir?
Trigonometric function is always differentiable. Okay, remember some tricks. Polynomial function, trigonometric function, these two functions are always differentiable at any point. At any point. Okay, so don't bother about the trigonometric function or polynomial function, and that kind of function will not be given in the exam, because always it is differentiable. You can find the differential and there is an easy question, and don't have to apply any kind of.
Yes, sir.
Suppose I am giving you an example like this. X is equals to sin x plus cos x. Is it differentiable at x equal to 0? Yes, obviously it is differentiable, because f dash x is equal to sin x means cos x, and cos x means minus sin x. And you know the cos x value at 0 is 1, and sin x value is 0. Okay, so it is equal to 1. Obviously, you are getting a real value of f dash x function. So simply sin x plus cos x, any trigonometric function, any polynomial function like x square plus x cube plus x plus 1 or whatever, all this kind of function are differentiable function. Okay, remember this.
Yes, sir.
That is why this is a very simple question, and it will not be given to the exam. This is very simple. And another thing, Just write it down. I'm giving you 2 points. First of all, a continuous function, a differentiable function, a differentiable, very, very important point. Function is always continuous. But a continuous function is not always differentiable. Very important point. And what is the example? You just did the example in the last day and today also, mod function, mod x or mod of x minus 10 or 100 or whatever. Okay, this function is continuous function, but this function is not differentiable always. Okay, but if a function is differentiable, suppose like sin x plus cos x, trigonometric function, any polynomial function, x square plus x or something, these kind of functions are always differentiable. If it is differentiable, okay, just you close your eyes and you can say yes, this function is always continuous. So differentiability implies continuity, but continuity doesn't imply always differentiability. Okay. Okay, so I just discussed about the differentiability of this one, so I don't have to discuss this now. Okay, solve this question. Okay, ACA. So So mod x is, I told you that x is x, that is plus x, if x is greater than 0, but a cube is there. So simply I would use a cube here, and is equal to minus x if x is less than 0. Okay, minus x if x is less than 0. Just put a cube here. Okay, and is equal to 0 if x is equal to 0. Okay, so just if I put cube here, so obviously we can see that minus x whole cube is actually minus x. Okay, so x is cube, it is x is cube, minus x whole cube, it becomes minus x whole cube, because this is odd number, the power is odd. So odd power is means the minus sign, it becomes minus sign itself. Odd power means minus is minus, it doesn't become plus. So it actually similar to the mod x function. It is equal to minus x if x is less than 0, equal to x if x is greater than 0, and equal to 0 if x is equal to 0. So it holds exactly the similar property as mod x has. It means it is continuous but not differentiable. Can anybody say if I change the function fx is equal to square, then what will happen? Is it differentiable or not? If I change the function as x square exactly, then it becomes differentiable. So remember, if the power is even, then it becomes differentiable. If the power is odd, it is not differentiable. Obviously at x equal to 0 point. Okay, I'm talking about x equal to 0 point. So this function even power means the function is differentiable at all these points, but odd power it means it is not differentiable. Next question. Okay, this is a very important question. Tell me the answer. I can find this question is almost means 7 or 8 times every every year's question and get. Yes, the answer is C. Always remember sin x by x, yes, 1. Limit x tends to 0, sin x by x is always is equal to 1. Okay, remember this. This is a theorem. Okay, this happens because the sin x is a bounded function, and sin x is a bounded between mod of sin x. If I say mod of sin x is always less than equal to 1, so that is why it happens. Remember this. This is always equal to 1. Very important question.
Sir,
Yes.
sir, n tends to plus infinity or minus infinity?
Hello.
Hello, am I audible? Hello.
Yes, you are audible.
Sir, may I know the n limit tends to minus infinity, sir?
No. N tends to infinity, not minus infinity.
Okay.
It's like this. D 0. No. No. None of the answer you have written in the chat box is right. Remember two things. Rules. Rule number 1. Limit n tends to infinity. 1 plus 1 by n whole to the power n is equal to e. Rule 2. Limit n tends to infinity. 1 minus 1 by n whole to the power n is equal to this one. That is 1 by e. So it means in this case we can write 1 plus, we can write this is equal to limit n tends to infinity 1 minus 1 by n whole to the power n square. Okay, so this is equal to limit n tends to infinity, this one, follow rule number 2, this equal to e to the power minus 1, is equal to e to the power minus 2. So B is the right answer. And if it is plus, always it is E. So if it is plus n, that is 1 plus 1 by n whole to the power n, limit n tends to infinity, this equal to E. And if it is 2n, then it is E square. And it is minus n, then it is e to the power minus 2. So remember these two rules. This is very, especially this one. It is very important rule. You need to remember. Okay, next. Mean value theorems, which is one of the most important topics in this chapter, that is unit 2, differentiability, limit and maxima minima, especially to find out the maxima minima. So in mean value theorem, the most important theorems are in your syllabus. First one is Rolle's theorem, second one is Lagrange's mean value theorem. Okay, so Lagrange's mean value theorem is the most generalized form. This is the generalized one, and which is after implementing here one condition, another extra condition C, it can be converted to Rolle's theorem. So just you need to remember this, because the sometimes questions may be from this theorem, that is some these conditions are given to you, then which of the following condition or following option is true. Okay, so 4 options is given to you from this theorem, so you need to remember this statement, this one, and the actual statement is this one. If I just simplify this, then the statement becomes this. We did nothing, we just multiply this b minus a with f dash b, that is just I'm it, nothing else. Okay, so both the things are same. So what is the statement? Statement is a function is given, real valued function, and which is continuous in the closed interval AB and differentiable in the open interval AB. So remember these two things. Any mean value theorem, whether it is Lagrange's or it is Rolle's theorem, always rule 1 and rule 2, that is condition 1 and condition 2 is satisfied. That is continuous in the closed interval AB and differentiable in the open interval AB. Okay, then there exists at least one point P in AB such that this theorem holds. Okay, I will explain the geometrical representation of Rolle's theorem, which is after which you can understand what the theorem says. Next, Rolle's theorem.
So can you please wait, sir?
Yes.
We'll just note it down.
Yeah, sure.
Yes, sir. Noted, sir.
Okay. So next one is Rolle's. Look at these first two conditions are same. Fx is continuous in the closed interval AB, differentiable in the open interval AB. A third condition is given if A is equal to FB. So if FA is equal to FB, obviously you can see if I put FA equal to FB, what will happen here? In this statement, if I put FA is equal to FB, that is these two are equal, then what will happen? This becomes 0, isn't it? The first numerator portion, FA minus FB or FB minus FA, this becomes 0. And if this becomes 0, so we can say that F dash P is equal to 0. So the same thing happens for Rolle's theorem. Third condition, FA is equal to FB is given to you, and for which we can say that F dash P is equal to 0. Now, what Rolle's theorem says? It is the basic idea of maxima and minima. Okay, so look at this. This is a function fx, real valued function, and 2 points, a point and b point, is given to you. The function is continuous. You can say that yes, in between this AB interval, this is a smooth function, and also this is differentiable in this open interval AB. FA is equal to FB. It means this is FA, this height. Okay, this is the functional value FA, and this is the functional value f of b. So what does it mean FA is equal to FB? It means that either the function is of this type or the function is of this type. Only at this condition we can find two values FA equal to FB. That is, look at this. Only if the function is, this is called convex style, convex, and this is called concave. So if the function is either convex or concave style, then this condition FA is equal to FB happens. Otherwise, there is no other function exists where FA equal to FB happens. That is, if the function is like increasing function like this, you can never find a point that is two different points giving you the same value, same functional value. If the function is decreasing function like this, you can never find the same functional value at 2 points. No, it is not possible because it is decreasing always. So only two functions FA and FB will be same if the function gives you, if the function is either concave or the function is either convex. Okay. Now What is this f dash p equal to 0? F dash p, it means the differential of this function. Differentiability means the slope. Differentiability f dash or ddx, it means the slope of this function. It means the point at which the tangent becomes parallel to the x-axis, isn't it? So look at this function. If I consider at this point the tangent is here. If I consider this point, the tangent is here. If I consider this point, the tangent is here. So at which point the tangent becomes parallel? At this point, and you can easily see this point is the maximum value of this function. So Rolle's theorem defines the maxima or minima of a function where the derivative is equal to 0. Similarly, if the function is convex like this, you can see that at this point the tangent becomes this. At this point the tangent becomes this. At this point the tangent is this. So only there is a single point in between A and B, this interval, this point, where the tangent becomes parallel to the x-axis. And tangent parallel means the derivative will be equal to 0. And suppose this point is a P point. So this is the statement of the Rolle's theorem. If the function is either convex or the concave function, then we can find the derivative is equal to 0 in between this interval. There is at least one point we can find where the derivative is equal to 0. That is either the function has some maximum value or the function has some minimum value. And which is obvious. If it is convex function, obviously this function has some maximum. If it is convex function, obviously we can find a minimum. This is very obvious. Okay, so why at least is used here? Because there may be more than one point. More than one point means, suppose the function is of this type. Then this is A point, this is B point. So you can find there is a maximum value, there is a minimum value, tangent is parallel to the x-axis. There is a maximum value, tangent is parallel to the x-axis. So there are 3 points we can get, this one, and this one. In between, tangent, that is, this is a maximum, this is minimum, this is another maximum. Okay. So this is the statement of Rolle's theorem. And from there, you can find the MCQ type of question. That is, a function is given to you. Find the value of C. Okay. A point where slope of the tangent to the curve 0 pi and differentiable over the interval open interval 0 pi. So you have to find out the point C, that is the point P here, which point the function becomes, the derivative of the function becomes 0. So the function is given as fx equal to sin x. The interval is given as 0, pi. At which point the function, there may be more than one point. In this particular problem, the function sin x function, okay, maybe this is 1 point, but the points may be 2 or 3 points. Only 2 students give the answer. Okay, so let's find out the answer. Fx, so you have to do nothing in this case. Whenever this kinds of rules theorem problem is given to you, just simply find the derivative, and you should equate the derivative is equal to 0. So what is the function fx equal to sin x? Just find out the derivative f dash x. What is the derivative of sin x? Is cos x. Okay, and you need to find out within the interval 0 comma pi, within the interval 0 pi, at which value cos x becomes 0. Within the interval 0 comma pi, at which value the cos x becomes 0. Cos 0 is equal to 1. Cos pi by 2 is equal to 0. Okay, cos pi is also not equal to 0. So only one point is there, pi by 2 point, at which cos pi by 2 is equal to 0. Okay, so remember there is only one point in between 0 comma pi where cos pi, that is cos x, is equal to 0. And what is the point? Pi by 2 is the point. So B is the right answer, pi by 2. Okay, these are the rules. That is, there are some rules. Sin n pi equal to 0, then pi equal to what? There are many values at which the cos x or sin x is become 0. Okay, all these rules are given in any 11 or 12 books. Okay, so just to look at the books, you can also you can find all the values of sin x or cos x. There is sin n pi equal to 0, sin 0, sin pi, sin 2 pi, sin 3 pi, sin 4 pi. All these values are 0. Okay, so you have to check it. Next, this one. Find the value of c. Here the function is given as fx is equal to sin cube x cos x, and the interval is given as 0 comma pi by 2. So how many values in between this interval 0 comma pi by 2 where f dash x is equal to 0? That is, first find out the derivative of fx, and then find out at which value of x f dash x becomes 0 within this interval 0 pi by 2. Any answer?
Excuse me, sir.
Yes.
Actually, first of all, we have to convert the sine cube into power must be reduced to 1, sir. So there's a special formula. Sine cube x formulas must be written first, and then we have
Simply just derivative, take the derivative of what is 3 sine square x cos x plus sine cube x cos x derivative is minus sin x. It becomes minus sin x. Am I right? 3 sin square x cos x, sin square x cos x and cos x. This is cos square. 3 sin square x cos square x. Yes. Minus sin cube x and cos x derivative is sin x. Yes. Now simply here you can, this is sin cube sin square x can be taken outside. It is 3 cos square x minus sin square x, isn't it? So either sin x is equal to 0, just put here equal to 0, either sin x equal to 0. So sin x equal to 0, it means x is equals to 0. Okay, x equal to 0 is a point. X is equals to, yes, 0 is a point. And if I convert, that is 3 sin 3 cos square x minus sin square x equal to 0, then it becomes sin square x by cos square x equal to tan square x. So tan square x is equals to minus 1 by 3, isn't it? Not minus, sorry, 1 by 3. 3 sin square in this side, sin square cos square, no, it is 3. Tan x equal to root over of 3. So at which point tan x equal to root 3? Tan x equal to root 3 at which point?
Sir, pi by 3.
Pi by 3. Okay, pi by 3. So pi by 3. So 2 points we have got. One is x equal to 0. Another is x equal to pi by 3. So now you have to check that within this interval, which point becomes. Yes, 0 point is also there. 0 point is obviously there because it is closed interval 0 pi by 2. Okay, so closed interval 0 pi by 2, but we can't choose 0 because look at this theorem. What is the theorem? Yes, look at this theorem. At least one point P in open interval AB. That is, the point should be in between this open interval AB. And if I say that it is an open interval and we can't choose this 0 point because this is open interval 0 comma pi by 2. Look at this open interval 0 comma pi by 2. So 0 point it can't be considered because always we are choosing this point, that is this C point, which is in open interval. So 0 point it can't be considered. So we have to consider is pi by 3. So C is the right answer here, pi by 3. Okay, so you can choose it. You can do this by this way also. If you have any other way to solve this problem, you can also apply that. But I think this is the most easiest way. Just simply take the derivative. And after taking the derivative, just put here sin square x common. And we are left with after taking sin square x common, just simple simplification. Okay, and this is equal to 0. So either sin square x equal to 0, it means x equal to 0 is 1 point at which this functional value tangent is equal to the that is derivative equal to 0. And another one is this one. And if I simplify this, that is sin square x, I am taking sin square x is right hand side into the right hand side, and cos square x then divide by cos square x. So it becomes tan square x equal to 3. So tan square x equal to 3, it means it is root 3 tan x. So tan x root 3, only there is pi by 3 point. So we are getting within this interval there is 0 point and pi by 3 point, pi by 3. 0 cannot be considered because the interval we have to consider as open. And open interval means 0 point, the end point is not included. Okay, so only there is pi by 3 point which is included. So C is the right answer here.
Excuse me, sir.
Yes,
Sir, isn't it pi by 6, sir?
pi by 6. चेक करना पड़ेगा मुझे. √3.
Is it 1 by √3, no, sir?
No, why 1 by √3? 1 by √3. This calculation is right or not? 3. This is right, no? 3 cos square x minus sin square x equal to 0. This is right? I think this is right. So it means 3 cos square x is equal to sin square x. So now divide both sides by cos square x. Divide both sides by cos square x. We are getting 3 is equal to tan square x. So tan x is equals to, yes, √3.
Okay, sir.
Isn't it? Maybe I am wrong. Because this is 3 sin square x minus, if this calculation is right, then obviously it is tan x equal to √3.
Sir, it's actually uv dash plus vu dash, no, sir?
Yes, u v dash plus v dash.
So it's nothing but u in.
This is first of all 3 sin square x. Sin cube x means 3 sin square x into the derivative of sin x means cos x. Already there is a cos x, so it becomes cos square x. 3 sin square x cos square x. Now plus sin cube x and the derivative of cos x is minus sin x.
Sin x.
Yes, minus sin x, so plus and minus becomes so this is right. Yes.
Okay, sir. Got it, sir.
Okay, so this is how you have to follow the Rolle's theorem. So remember, there is more than one point. There are more than one point in between an interval for which the derivative becomes 0. Okay, but you have to choose which lies in between the given interval 0 pi by 2 or the given interval. If the interval is extended, obviously you have to choose both the points 0 and pi by 3. Okay, if the interval is minus pi by 3 and pi by 3, so obviously you have to choose both the points x equal to 0 and pi by 3 both. So I think it is clear to you. So mean value theorem is completed here. Next, maxima minima. Okay, there are two kinds of maxima minima, and every year you will face at least one question of maxima minima in GATE exam. Every year it is mandatory to come. So maxima minima, there are two types. First of all, you have to check that the number of variables in the function. Okay, first of all, the function is like this fx, where the independent variable, the number of independent variable is equal to 1. This is called function of single variable. Second is function of several variables. An example, suppose f of x, comma y, comma z, comma dot dot dot. Okay, so two types of function is there. One is single variable function, another one is several variable function. So single variable function maxima minima is very easy. Several variable function in GATE exam, functional value, that is the number of independent variable, not more than 2. In general, you will face f of xy type of function, not more than that. Okay, so first I will explain the maxima minima of single variable. Then I will complete the several variable also within this day. Method is very easy. First find the derivative. Step 1, find derivative. and equate it to 0. Okay. Step 2, find the values of x. Find the value or values of x. Okay, that is after taking derivative just like this. Already you have done this. That is, you are given with this function. Look at this, sine cube x cos x. You take the derivative f dash x equal to 0, and which becomes this. And what are the after now equal to 0? F dash x equal to 0, you equate this derivative equal to 0, and then you have found two values of x, 0 and pi by 3. Okay, so just like this, I am saying this exactly similar thing. First find the derivative of the function, and then find the value or values of x after solving the equation. Okay, already you have done these two steps. So these values of x after finding, so I am considering this example. So after finding the values of x, 0 and pi by 3, either at these values the function has maximum or the function has minimum value. Okay, now how can you understand that the function is attains maximum value or minimum value at that point or not? So the condition is find second derivative, find double derivative. Okay, at that point of x. Okay, so that is after taking the derivative you found that x equal to 0 and x equal to pi by 3, 2 points are there. So find double derivative of fx, that is fx function is this one. Now you have to find the double derivative and put each and every, and then put x equal to pi by 3. If the value of the second derivative is positive, then it is minimum. If the value of second derivative is negative, then it is maximum. Okay, very simple. If the value is positive, is greater than 0, then minimum. Otherwise, if 0, maximum. Less than 0, maximum. Remember, if the point of the second derivative is equal to 0, then it is called point of inflection. Point of inflection. So second derivative is greater than 0, minimum value. Second derivative less than 0, maximum value. Second derivative equal to 0, it is called point of inflection. We cannot make any decision at that point. Okay. So simply now tell me the answer of this question. Already you have done partial maxima minima, that is taking derivative and equal to 0, you have found the values of x. And rest of the part is find the second derivative and put the values of x. And if it is maximum, then greater than second derivative greater than 0, minimum less than 0, maximum. So try this question now. Okay, 1 minute more. Okay, now I am solving it. First of all, in case of MCQ question, always there is a trick. You don't have to do anything, just simply take the second derivative. Okay, look at the answers, look at the options given to you. Whatever the tricks you will apply, everything depends on the options given to you. So look at the options. Already the points are given. It means you don't need to find out the first derivative and take it equal to 0 and then find the points. You don't have to, you have to skip, you can skip the first step. That is first derivative and is equal to 0 and find the value of x. You can skip this step because already values are defined here. Just what you have to do, just to find out the second derivative, put the value. And just to find at which point it is greater than 0 and which point it is less than 0. So I will show both the steps, that is both the tricks. First of all, simple normal method. First, f dash x equal to 0. F dash x equal to 0 means fx equal to this function. If you take the derivative, it becomes 3x square. It is 12x and plus 9 equal to 0. Okay, so if I just take 3 as common, minus 4x plus 3 is equal to 0. Okay, so 1 and 3. So if I put 1, it is equal to 0. If I put 3, it is also equal to 0. So obviously, x is equals to 1 and 3 are 2 points. Now, this tip, because 3 and 1 is already given in the answer. Next, what is your duty? Find the second derivative. Second derivative is, again, take the derivative of this one. So 6x and it is 12 minus 12. 6x minus 12. Am I right? Now put values of x and values of 3. First we put x equal to 1. First we put x equal to 1. So f double dash 1. F double dash 1 means 6 into 1 minus 12. Minus 12. So 6 into 1 minus 12 is equal to what? It is negative, less than 0, minus 12, isn't it? Sorry, minus 6. So x equal to 1, it is minus 6 and it is less than 0. So less than 0 means at x equal to 1, it has a maximum. So x equal to 1, at x equal to 1, the function fx has maximum value or maxima. Now again, another 1 point is left, which is 3. So put now x equal to 3 here. So f double dash 3. 6 into 3 minus 12. 18 minus 12, which is greater than 0. So at x equal to 3, greater than 0 means minimum point. If x has minimum. Okay, so x equal to 1 means it has, at x equal to 1, it has maximum value. So maxima at x equal to 1, A is the right answer. And minima at x equal to 3. A is the right answer. Any doubt?
No, sir.
No, sir.
Okay. So remember the trick. If you if everything depends on the answer, everything depends on the options given. If values are x values are already given in the question, don't have to. You can skip this portion. Just simply find the double derivative of x and put the values. You can easily find the answer. Next. Solve this one. E to the power y equal to x to the power 1 by x. Then y has what? I can give you a hint. Take log both sides. It's log of now solve it. Okay, you can directly take the second derivative. You can directly take the second derivative here. Also, you don't have to find out the values of x. It is also given, already given in the options. X equal to e, there are two values. So you can find x equal to e and x equal to e to the power minus 1. That is 1 by e. So put those values into the second derivative of the function, and each point it becomes greater than 0 and or less than 0 and nothing else. Okay, so let's try for this question. So first derivative, if I say y dy dx, so dy dx is equal to, it is 1 by x first. So you can say, you can see that there are two functions, 1 by x and log x. Okay, so simply you can apply uv rules, u into v, v dash u plus u dash v. So 1 by x means the derivative, what is the derivative? Minus 1 by x square log x plus 1 by x, log x means 1 by x into 1 by x, so it becomes 1 by x square. dy dx. Now d2y dx2. So d2y dx2, it becomes okay. One thing you can do, you can find the values here also. This equal to 0, if I find this equal to 0, it becomes minus 1 by x square log x minus 1 is equal to 0, isn't it? So it means log x minus 1 is equal to 0. Okay, log x minus 1. It means log x is equal to 1. So it means x equal to e. So only one point you can find e. That is x equal to e. So either it has maximum or it has. Now you find the second derivative.
So, excuse me, sir.
Yeah.
So log inverse of, which means anti-log of 1 is e, sir.
Yes. Anti-log
But
of
when I'm seeing in the calculator anti-log of e, I'm getting 10.
No. Your in your calculator, the base is taken as 10. Okay, shift the base as e base, ln. Do not use log. If you are using scientific calculator, take ln, not e. Okay, always take ln in case of derivative.
Okay, sir.
By the definition, log, if I simply put log, it means in the scientific calculator it is defined as log base 10, not log base e. Okay,
Yes.
but in mathematics, in derivative case or these cases, we are using log, and that log, it has the base e. But this in the programming, calculator programming, it is not defined as e. It is, so ln is defined there. Use ln always.
Okay, sir.
Now d2 by dx2. It becomes plus 1 by x cube. Okay, 1 by x cube and log x plus, that is minus 1 by x square into log x means again it becomes 1 by x cube. Okay, and it becomes 1 by x square minus 1 by x cube. Okay, this is, it means 1 by x cube log x minus 2 minus 2 minus 2. Sorry, I think I have did something wrong. X square 1 by x square. It is okay. This is okay, but here it is 2. It's 2.
So like it is uv dash minus vu dash divided by v square.
No, not v square. V square is u by v formula.
Ah, yes, sir. U by v. Yes, sir.
Yes, it is not u by v. It is u into v. Okay.
Oh,
Becomes it is minus of 2 by x cube. Yes, 2 by x cube. Minus of 2 by x. Yes, minus of 2 by x cube. So it is 2 by x cube and 1 by x cube. It can be taken common. So it is 2 log x minus 1 minus 2. So it means 1 by x cube 2 log x minus 3. I think this is the answer. Now if I put log x equal to e, x equal to e means 1 by e cube, and x equal to log e, it becomes 1, 2 minus 3. Yes, it is minus. Minus of 1 by x cube, it is less than 0. It means it has maximum. Maximum at a is the right answer. Maximum at x equal to e. Okay, if I put log of x, that is, if I put x equal to e here, log e means it is base e. So log e of e is equal to 1. Okay, so it is 2 minus 3. 2 minus 3 means it is minus 1. So minus of 1 by e cube. Minus 1 by e cube means it is less than 0. So a is the right answer. Okay, out.
so 1 second, can you just explain the differentiation part alone, sir?
Okay, which differentiation, first or second?
Second one, sir. Because I considered it like u by v.
Okay.
So if we take u by v also, the same answer only will be coming, no, sir?
U by v, log x by
Log x.
yes,
Log
yes,
x
yes.
by
The
x.
same answer. Exactly. Same answer you can get. So second derivative d2y dx2 is equal to, look at this. First take the derivative of this one. I'm taking the multiplication rule, okay, not division rule. So first take the derivative of this one, minus 1 by x square. Minus 1 by x square means minus of 2 by x cube. So minus and minus, it becomes plus. The derivative of minus 1 by x square is 2 by x cube. Okay, log x plus. Now take the derivative of log x, and minus 1 by x square is taken as constant, and log x derivative is 1 by x. Okay, so this is the derivative of this one, plus derivative of 1 by x square is minus 2 by x cube. This is the second derivative. If I simplify this, after simplification, you can get 1 by x cube, it can be taken as common. It is 2 log x minus x cube, it can be 1 minus 2. So minus 1 minus 2, it is minus 3. Okay, so 1 by x cube into 2 log x minus 3. This one.
Yes, sir. Understood.
Okay. Any doubt? I think it's clear to you how to find out the maxima and minima.
Yes, sir.
Okay. Now I will start the partial derivative, because without partial derivative, you can't understand the maxima minima for function of several variables. Okay. Before that, I am taking 5 minutes rest. I am coming because I have to complete this partial derivative by today. Half an hour is remaining. Okay, am I audible to everyone? Am I audible?
Yes, sir.
Yes, sir.
Now it's a partial derivative, but I have remember partial derivative always occurs in case of function of several variables. That is, more than one independent variable is there. So far we have learned the function which is y equal to f of x. It means it is function of only one variable x. But if the function has more than one variable x, suppose x1, x2, x3, like this. So in this case we have taken dy dx, which is a single derivative, or the derivative of function of single variable. So only one independent variable, so only one derivative is there, dy dx. And second derivative d2y dx2, third derivative d3y dx3, and so on. But when number of variables are there, a number of variables, so at each and every independent variable we have to take the derivative. That is, we can take the derivative with respect to x1, we can take derivative with respect to x2, with respect to x3, and so on. In this case, we will say this is a partial derivative, that is del y del x1, del y del x2, del y del x3, and so on. So in this chapter, I will only talk about function of z equal to f of x comma y. That is only two variables, not more than that, because not included in syllabus. Okay, so only two variables means we have to take derivative only two times, that is one with respect to x and another with respect to y. So we can write del z del x, we can write del z del y. When we are taking derivative with respect to x, y should be constant, and when we are taking with respect to y, x should be constant, such that suppose f equal to x square plus y square. This is a function. So how many variables? Two variables are there, x and y. So we will take two derivatives, del f del x and del f del y. When we are taking with respect to x, it means only x is variable, the entire y square is constant here. So the derivative will be 2x. Whenever we are taking with respect to y, only y square, that is y is taken as variable, the entire x square should be constant. That is, the derivative is 2y only. Okay. And how to find out the second derivative? You will say that yes, obviously the second derivative is del 2z del x2, and in this case we can write del 2z del y2 and nothing else. No, there are another two derivatives. If I am saying that there are two variables, second derivative can also be taken as like this, del z del 2z del x del y del 2z del y del x. So not only we are taking the second derivative, that is a double derivative with respect to x. Also, this double derivative, that is del 2x del x del y, that is, this means first we need to take the derivative with respect to y, and then we have to take the derivative with respect to x. Similarly, in this case, we have to take the derivative with respect to x first and derivative with respect to y then. Okay, just simply as an example. So these four types of derivative I will explain with this function z equal to x square plus y square plus 2xy, suppose. Okay, so del z del x is equal to what? Del z del x equal to 2x. Y square is constant here, plus here 2xy, only y is constant, but 2x is 2 is constant, y is constant, x is variable, so it is 2y only. Del z del y. So del z del y means 2y plus x square is 0 because x square is constant. Similarly, from 2xy we can get 2x. So same 2y plus 2x, or it is 2x plus 2y, it is same. Now del 2z del x2. Del 2z del x2 means take the second derivative with respect to x here. So it is only 2 because y 2, it is also 2. Now come to del x del 2z del x del y. Del 2z del x del y. This means it is del x of, that is, we have to separate these two parts. First one is del x and second one is del y. So del x of del z del y. This means this and nothing else. So remember that what is in the right hand side, that is right side portion, that is del y portion, is considered first. That is, we have to take the derivative of with respect to y first and then take the derivative with respect to x. Okay, so if the function is x square plus y square minus plus 2xy, then it becomes del z del y, it should be taken first. So del x of del z del y means this ends 2x plus 2y, and then take with respect to x. With respect to x means it is 2 only. Okay, most of the time del 2z del x del y and del 2z del y del x are equal. Most of the time these two are equal. Okay, so in your exam, because you are in engineering students, the unequal, these two derivatives are unequal, these types of examples are will not be in the gate questions. Okay, if it is purely mathematics gate, then there may be that kind of questions where these two derivatives are unequal, but in your case these types of that type of questions will not be there in gate questions. Okay, but so remember that in many times you can find the any one derivative, you don't have to find out the another one because both are equal in general. Okay, so these are the any question about this partial derivative?
No, sir.
No, sir.
Then solve this one. Okay, so now I will solve this question. Y to the power x. Take log both sides. Okay, f is equal to y to the power x. Whenever this power type of things you can get, always take log. Log of f is equal to log of y to the power x, and which means log of f is equal to x log y. Take the derivative both sides. Okay, now you can take the derivative with respect to x, or you can take the derivative with respect to y. Okay, y to the power x is a continuous function, so at each and every value of x, so xy, so it can be taken as any derivative you can take. Either first actual del to f del x del y, it means that del x of del f del y. So according to the rules, first you have to take the derivative with respect to y. Okay, first you need to take the derivative with respect to y, but you can take derivative with respect to x also. Okay, so okay, I'm taking derivative with respect to y. So it means log f. So it is 1 by f del f del y. 1 by f, because log f, the derivative of log s is 1 by f. Okay, so 1 by f and del f del y is equal to x log y. Okay, you can first take derivative. So log y means 1 by y, 1 by y, x means x, plus it becomes with respect to y, it means x becomes constant, so it is log y. Okay, so this is x by y plus log y. Okay, so del f del x, sorry,
So when x
sorry,
becomes constant, so it becomes
exactly,
zero.
exactly. I just did the mistake. Y means it is x only 1 by y. Sorry. Okay, so del f del x, it becomes now f. So f means y to the power x. Okay, so y to the power x, so x into f, if I multiply f here, so it becomes f into x into 1 by y. So which is, put the value of f means y to the power x, so x into y to the power x into 1 by y.
So it's dou f by dou y, no sir?
Yes, y to the power, so it means x minus 1. Okay, now take the second derivative. Second derivative means now it is with respect to x. del x of del f del y. Del f of, now just you can use the UV rule. Take x as u and y as v. Now x means del x. Del x means it becomes x is the variable, y is the constant here. So y to the power x, it becomes f. So you can take the derivative. I think it becomes 1. If I put y to the power x minus 1, it is y to the power x into y to the power x minus 1. This becomes x into y to the power x minus 1. And ln y. Ln means ln y. Yes, 1 by y ln y plus y to the power x minus 1. X minus 1 because x derivative is 1. So y to the power x minus is x. So y to the power x minus 1 ln y. Yes, x minus 1. Yes, this becomes this one. Now if I put the value at x equal to 2 and y equal to 1, x equal to 2 and y equal to 1, it means 2 into 1 to the power x minus is 1, y equal to 1 means it is log 0, it becomes 0, plus y to the power x minus 1, y is 1, x is 2 minus 1, it is 1, 1 to the power 2 minus 1 equal to 1 is the answer. So 1 means C is the answer. Okay, so it is already 8:03. I have to complete the class now. Any question or any doubt, if you want to clear, then I will discuss in the next day. And also I have to complete the partial derivative is completed. Now maxima minima of function of several variables. This is remaining. Okay, I will complete it the next day, and also after that this chapter will be completed, unit 2. And next day I will start vector. And I think vector will be completed in just 2 hours. It is you can take only 1 day. The most part is differential equation, which I have to take at least 4 hours. That. Okay, so I have to close the meeting today. Thank you for attending my class.